And so with that, I'd like to welcome everybody to this webinar yet again. My name is Maya Karlsfeld, and we're going to be doing a webinar on EV infrastructure training program. It's an information session that's going to be run by Neil with the EV infrastructure training program over in Port Coquitlam, I believe. And today's like the first of a couple different webinar sessions. So I'm really excited to have you guys here today as our first cohort. This is really exciting. And just a quick reminder on some Zoom etiquette that for the most part, if you can stay muted unless you're invited to unmute, or if you have a question during the Q&A section, we do have a fairly small number of folks today. So it's not a huge deal if you need to unmute to ask a question, but just generally for the sake of making sure that everyone can hear clearly, it's a good idea to kind of stay on mute. If you do have questions throughout, we absolutely invite you to throw some comments in the chat. So the chat can be found at the bottom of your screen. There's, if you go scroll down to the bottom of the screen on the Zoom thing, there's a little like chat bubble icon. Click on that. It should open up a side panel for you to be able to type questions there. And also, if you are comfortable with doing so, you're welcome to turn your video on, and just keep in mind the session is being recorded, so only do it if you're comfortable. However, this is a really great way to help kind of feel like you're more in the room and it's a little more personal than a bunch of black boxes. So if you're comfortable to do so, we invite you to turn your video on. So super quick, just going to go through a bit of an agenda here. I want to give you a little tiny overview over the program Charge Your Ride, which is what is facilitating these webinars and happening in the CRD here. I'm going to do a little territorial acknowledgement, of course, and then we'll be passing it off to Neil with the Electrical Joint Training Committee. And Neil has a pretty robust presentation for everybody, so that's really exciting. We're going to get into some really great information. There will be a short bio break somewhere in the middle there, and towards the end we will have time for questions and answers. So it's going to be a pretty packed schedule today, but I'm really excited to get started. So Charge Your Ride is the electrical mobility campaign that we have going on here at the CRD. It's funded by NRCan, so a federal grant was the main part of our funding here to be able to provide this program to you. And we've done multiple public outreach events over the summer, really focusing on getting people out in electric vehicles and onto e-bikes, trying to break down some of those barriers and answer questions that people may have. And right now we're starting up the second component of it, which is really trying to get in touch with those of you who are working on these vehicles or working on the infrastructure that we need to use to maintain these vehicles. So that's where this webinar is coming from. So I'm really excited to have you all here. And of course, the Capital Regional District encompasses quite a large area on South Vancouver Island. So here we have a map of all of the different municipalities and electoral areas that are within the CRD. If you're comfortable doing so, it'd be great to hear where people are calling in from. So if you want to pop in the chat, or if you would like to unmute to let us know where you're calling in from, that'd be great. And also maybe let us know, like, how long have you been working with EVs, or what's your interest in today's webinar? That'd be really great to know. So feel free to pop in the chat where you're coming from. Today, I'm calling in from the Victoria area here. And I did want to mention that, of course, we are operating, we do business on an area where more than 20 First Nations identify this region as their traditional territories. So although I said I'm coming in from Victoria, that's also the traditional territories of the Lekwungen speaking peoples. So if you wish to share where you're calling in from the traditional territory name, that's also perfectly welcome, and we'd love to hear from that. Okay. And I'll bring this slide back up at the end as well, but just to let you know that there are more events coming down the line. So you can always find them at crd.bc.ca/charge. And I'll pass it over to Neil.
Thank you very much, Maya. Hi, everyone. My name is Neil Normando. I am out of Port Coquitlam, and I do work and represent the Electrical Joint Training Committee. And today we will focus in on our EVITP program, but primarily as well to some of the industry secrets and some of the little nuances that may or may not be known. Now, our program itself actually is a significantly longer, more robust. This is just an overview, but as well allows you to kind of explore a little bit of what the system and as well the industry kind of looks like. Now, it may not be a mystery to a lot of people as to what actually I will be talking to you guys about today, but at the end, it is definitely an eye-opener. There may be some things that you may or may not know of, but this is the reason why we're here. I'd be more than glad to introduce and answer any questions for any of the items that I do talk to you guys about today. So anyways, our program is EVITP. It is today done through the E2 Inc. Banner, as well actually with our partners of Netco, which actually hosts the program. And I can talk to you guys a little about that afterwards. Okay, so to gain a little context about the existence of the program, a little again about some numbers as to the idea of promoting it too, is that for one, we are aware that greenhouse gases and as well the emissions in Canada grew by 19% overall between 1990 and 2017. So a significant portion of this growth has been driven by the increases from the oil and gas transportation sector. The transportation's related GHG emissions increased 43% over that same time period. Now, the deployment of electric vehicles do present an enormous opportunity to address emissions in the transportation sector. Now, it's not the only answer to the problem itself, but it definitely helps to curtail some of the emissions created by transportation. So now in Canada, over 80% of the country's electrical generation does come from non-emitting sources. So from hydro, geothermal, wind, but these are all, again, additional sources that are becoming more prevalent as a sustainable solution and also contributes to increasing electrical needs. EVs can contribute to Canada's clean growth and climate change strategies. Will stimulate best practices in energy efficiency and clean technology. It does also play a critical role in the broadening landscape, such as renewable distributed energy, storage technology and research, and as well to the development and demonstration of new technologies as well.
Hey, Neil, are you going to be sharing your screen?
Yes.
Okay.
Oh, actually, it's not being shared. My apologies.
It's all good.
And
Just
I
wanted
did
to
say
check
earlier
in.
that I was experienced with this. Yes. So I will get into this right away. There we go. My apologies about that. And I just need to. Perfect. Is that better? Excellent. Okay, thanks for the notice on that. Okay. Now, as of 2016, Statistics Canada reported that 28% of private dwellings were apartments. And this is basically identifying that apartments refers to building types rather than ownership type. But it's also including this in both low and high-rise buildings for not duplexes. Now, for census metropolitan areas, the number was even higher at 35%. Now, my slide reasoning for this was because nationally, installations will reflect a balance of both residential, also multi-unit residential buildings, and it's also getting into more commercial properties. But the census showed that condominiums represented an increased percentage of new dwellings being constructed between 2011 and 2016. Now, additionally, the industry must consider that most, if not all, metropolitan areas have an existing footprints of multi-unit residential buildings, which are considered or called as MURBs. It represents an opportunity for the industry to help modernize existing infrastructure and also advance the electrification of our transport industry. Considering the installation criteria for a single family dwelling versus an apartment, the complexity of the installation does change. Factors to consider, but they're not limited to, are going to be dealing with stratas. And so for those who don't know what a strata is basically the building organization of owners that manage the building. So strata and customer consultations, where the contractors may need to help advise and develop plans that would best suit the owner's needs. Also helps determine the different cost options based on equipment, charging strategies, and also future considerations to navigate the possible engineering requirements, because depending on the building's unit capacity, service size, and load requirements, the utilities and municipalities may need to have an engineer sign off on the installation. Additional considerations are municipality requirements, equipment selection. So depending as to the equipment that is going to be best suited for the installation on either your low-level systems or your high-level systems. There's also documentation. So the requirements for municipalities, the utilities, this all comes down to the rebates required, and as well for the engineering tying off on this as well. And last but not least, essentially the requirements for utilities. Now, considering the installation criteria for a single family dwelling versus an apartment, the complexity does change. So some of the factors to consider are going to be, again, as indicated, strata, customer service, possible engineering, municipality, equipment. But for the most part, depending on the systems, the Canadian standards and regulations for most municipalities will differ when it does come to the installation of EV infrastructure. Now, when I do look at possible engineering, we are depending on the building's unit capacity, their service size, the load requirements, utilities of municipalities may need to have an engineer sign off on the installation. When we do look at the equipment selection, because again, there is no one system that is best suited or that is going to be identical, but the functionalities may be best suited for one particular aspect, whether you're looking at networked systems versus systems that are just load sharing or just standalone systems. And if you're going to then go into more and larger expansions, whether you're looking at level 1, 2, or 3 charging infrastructure. Additional functionalities, I didn't mention something about networking, but another one is energy management, service hosting, whether it's going to be used for retail purposes, so you are looking at monetary purposes. And then you got to consider the cost functionality too. So the cost may increase based on these extra needs. Now, documentation, I did mention that permits are going to be required, rebates, which are a big thing now from a federal and a provincial level. EV ready plans. These are certain things that are required from the utilities perspective, and the EV ready plan needs to be formulated correctly to be able to take advantage of those. And additionally to charging plans. So if you're going to be using it for retail, so if you're going to be using it to make money off of it, you also have to understand that other parts of Canadian legislation are required for pretty much understanding, like you can't charge based on the kilowatt hours. You have to base on either parking spots unless you want a metered system. And then as well, low proposals for the utilities and the rebates that are tied to that. Now, with an increased demand for EV solutions, standard practices have to be introduced to maintain industry integrity. The supporting program for infrastructure installation is EVITP. Now, this isn't primarily a promotion to EVITP. It is addressing that as a program that was designed to address the installation as well and maintenance needs of EV charging infrastructure in a safe and also a cost-effective manner. The program itself was originally created in the United States, but has been adapted for Canadian industry, as well to basically to keep into the standards and as well to the electrical code. I did mention at the very beginning, NETCO, they are the ones who hold the license for the distribution of the EVITP program and is also responsible for the certification of its members across Canada. Now, the program also requires specific entry requirements, such as we want to make sure that it's pretty much people who are going to be introduced, such as contractors, whether you are a red seal electrician, and as well with the intent to be able to work in the industry. So it's basically managed by expert instruction, and the demanding exam at the end maintains that there's strong comprehension to the program, that you do maintain certain performance criterions to the installations, and as well you'll get consistent training results across the province, or whoever actually does take the program. Now, the program was developed in collaboration with industry. So it's not just someone's little pet project and say that this is what you're going to use as the benchmark for systems, but EVITP does offer the perspective of automakers. It does offer utilities perspective as well, and also EVSC equipment. So the actual installation of the charging equipment. We do have manufacturers that have a key stake in this, and additional key stakeholders associations to pretty much maintain the structure of our program. Now, the EVITP collaborative understands the importance of the EV market being properly supported due to items such as market demand requirements, the evolving technologies in vehicles, charging infrastructure, and as well energy distribution, and evolving regulations at federal, provincial, and also municipal levels. So understanding the electrical codes, the technical bulletins, and anything else that does come under those boundaries. Now, the one thing that I do want to make as a declaration is this course doesn't focus on teaching electricians and or contractors the methodologies of equipment installation. EV charging is basically electrical equipment. And again, full disclosure, primarily most EV installations is just a 240 volt connection, and depending as to the demand requirements, you can install anywhere between 20 amps all the way up to 80 amps on certain systems for home and business purposes. So it's an electrical device. It requires power, and it's going to be delivered by electrical infrastructure. So if you're thinking as to why should this program contribute to my knowledge of these installations, well, the focus of the industry in relations to EV infrastructure is to introduce installation best practices, understanding the electrical code and jurisdictional requirements, also understanding emerging technologies, because the systems and as well as the demand for EVSCs are essentially starting to swamp the market, that you are going to have an increase in technology systems that may or may not necessarily be the same from like 2 to 3 years ago. So it's like anything else, technology can stagnate, and you actually have to maintain some common knowledge to these evolutions. Also, we focus on safety and as well customer service. Now, looking at best practices, I do kind of focus in on a few things, not all, but for the most part. The basis is on a few things where the intent is to have an electrician or a contractor understand equipment specifications. So when consumers' needs are constantly evolving, it forces equipment manufacturers to adapt to quite a few things, such as the need for faster charging times, simpler user interfaces, programmability, and as well as safety. The need for expandability is also pretty much of greatness today. So understanding open charge point protocol, so the OCPP protocol for a lot of these devices, and also understanding system obsolescence. So if you consider that you might buy a system today thinking that it was a great deal, and it was a kind of like a little manufacturer that you thought would sustain the makes of time, may have gotten bought out eventually, and then all of a sudden you look for that particular manufacturer and it's no longer available. It might be under a different manufacturer, or it's just they've closed shop entirely. So some of these things actually have to be considered, because if this is what you were basing your installations on, it may actually become much more complicated if you're trying to do upgrades or keep up with the systems as well. And also understanding system limitations. So there are going to be communication protocols to understand fail-safe controls for EVMs, which is like essentially the energy management system, and to also understand how to navigate manufacturer support. As electricians and contractors, we are aware of equipment standards, so CSA, UL, and anything else that pertains to what our jurisdictions allow. So in North America, there are going to be differing equipments specifically for the connector, pretty much for the system. So as a protocol, in North America, the standard is J1772 versus the European Type 2 plug, which is the Menike's type. Then there's also going to be for fast charging protocols, the CCS1, which is the North American, versus the CCS2, which is the European type. Now, it's not as if you're going to go to a wholesaler and purchase anything that is meant for the European market, because it just doesn't exist. But it's to understand that these particular standards are worldwide based on vehicle manufacturer requirements. But last and not least is our electrical codes. Back in 2018, when the adaptation of the CEC came in place, they introduced Section 86. And this is specific to EV charging equipment. So it integrates with other rules within the CEC, but basically it just focuses on the needs of EV charging equipment, and it's pretty much ingrained towards the very end. Now, additional things to understand is that the electrical codes can also have integrations with EV structure for renewable energies. So now, as we are getting into greater options for energy production, such as solar, wind, geothermal, etc., there's also the energy storage and batteries, the whole bit. All of these can be integrated together, especially knowing that you can have electric vehicles become the energy provider as well. So this is all provisions that have been brought into with the electrical code. Now, still on best practices here is that when we are dealing with EV charging equipment, we know that it's designed for use by the public. Additional installation requirements have to be met to satisfy the national and local business codes. Anytime that you are dealing with infrastructure specifically designed for public services, there is definitely going to be a greater presence of such as like the federal, if not provincial requirements to make sure that people don't get hurt, nor does property. So now, one of the biggest things for electric vehicle equipment is going to be accessibility requirements. So we are essentially looking at the requirements that govern the location as well as configuration of EV charging infrastructures. So things such as connector height above ground, also looking at the cord's weight, as well the cord's reach, access to the charging device, which is imperative for accessibility, and as well the connection pressure for the user. So all of these things have to be taken into consideration, and it is always going to be an evolving requirement for this particular industry. One really good example to accessibility requirements is to look at a refueling station today. If you were to compare what a refueling system looked like back 10, 15, 20 years ago compared to how it is today, you'll notice that everything is at a lower height and as well to the front. And this is the same for EVSEs, that these are adapting practices for the industry. Additional requirements for EV charging equipment is going to be the safeguarding of your EV charging infrastructure, so mechanical protection. When installed either in a public infrastructure such as a parkade or in a parking lot that is open to the movement of vehicles, requirements such as bollards, steel guards, or anything to make sure that the equipment doesn't get damaged. These are criteria that are required by the building code for either provincial or federal jurisdictions. There's also the notification requirements, such like likely guided by municipal requirements. So for signs, parking space and paint, and as well as height of signage. Now, whenever I do deliver these programs, lot of people ask me, well, why would I be concerned about the signs? Why would I be concerned about the parking space paint or even the height of the signage? And usually I identify with the contractor or the electrician to say a lot of times that you are the general contractor for an installation that will require for you to deal with all of these pertinent details. So it's not always going to be a large project where it could just be small, but at the end of the day, still understanding all of the municipal requirements is imperative. Now, when we do look at the Canadian Electrical Code, there are a reasonable amount of information that will allow us to do the installation of EVSEs. And it's not just going to be stuck to Section 86. Now, I am not going to spend the time today to go through every single rule, but I will try to point out a couple of the areas that are really important. And just again, it's just one of those things in practice that if you don't use the code book often enough, then you forget about certain little nuances that are really important to our installations today. So the CEC does have provisions required for the installation of EVSEs, which is basically universal across Canada, except for a couple of provinces. Now, looking at Section 2, we understand that those are general rules, but I'll move on to Section 4. And when we do talk about Section 4, it's primarily about conductors, and this is dependent on the location of your installation, how the installation requires service or conduit that is going to be based underground. Special attention required in the planning and as well as the installation of conductors for EV charging infrastructure. Section 6 does talk about services and service equipment. Some installations are not necessarily tied to existing infrastructure and are going to be standalone systems. So when we look at highway rest stops, parking lots, street parking, they do require their own utility connection and as well as service equipment. Looking at Section 8, talking about service circuit loading and demand factors. Loading requirements will differ based on the installation methods and as well the building type. So the application of an EVSE to a single family dwelling is relatively straightforward unless the demand does exceed the available capacity. And this is where you can then introduce energy management and alternatives that can be introduced to allow for charging infrastructure to be installed and to minimize installation of costs. So I'm going to focus in on this for a couple of seconds here is depending what your installation procedures are, or to say if you actually work in the residential versus commercial industry, we have a tendency of looking at EVSEs and we're thinking residential right away because it is going to be for public service and use. So the installations are very simple, but understanding that if you don't have the necessary energy within your service, that you may not be able to do that installation unless a few things happen, such as a service upgrade. And if you've done any of these, that they can be quite significant in costs. So from my understanding from when I was doing contracting, then certain costs actually, depending as to how big the installation is, can vary between $5,000 to $7,000, and that's just in the best case scenario. So the introduction of additional cost to a consumer may actually turn them away from actually doing the installation, but then to compromise on energy management, this is where that alternative can be introduced. And simply will give them the incentive to, again, do the installation at a minimal cost. In Section 8, there's also the mention of a table that allows you to do EVSE installation on properties that are not considered a single dwelling. And this particular table, it kind of looks into the account of how many parking stalls in relation to the equipment being installed. And depending as to that, then it will identify how to do the circuit loading at a percentage rate. Now, we can never discount any of the other sections, such as Section 10, which is grounding and bonding. That is self-explanatory. Section 12, wiring methods, pretty much the delivery of all the your wires and how to basically get them all connected properly. Section 14, the protection and control. Section 16, which talks about Class 1 and Class 2 circuits. Now, Earlier, I did mention that the installation of EVSEs is straightforward, 240 volts, so you have two conductors, your bonding grounding wire, and that's it. But if you have to introduce any form of communication or data linking that would require for you to introduce extra low voltage circuitry, then Class 1 and Class 2 circuits have to then be considered during that installation. Oddly enough, the introduction of EVSEs in hazardous locations sounds counterintuitive, but it isn't. Just because when we do look at EVSEs, we have to look at markets that may go further than just your standard road vehicle. You may have to look at mining vehicles, may have to actually look at vehicles that are going to be in locations where hazards are reflective of the industry. And last but not least, looking at Section 20, refueling stations. And generally, we would have thought that they would not have introduced this kind of thing because it counters what their general business model is going to be. But more and more are you going to be seeing refueling stations with the availability of fast charging just because it makes business sense. Refueling stations are not just for the introduction of people needing a specific service, which is refueling, but it also provides a stop break where there's other business opportunities to be taken. So if you're looking at all the rest stops for retail, it makes perfect sense. So the industry caters to transportation. Refueling stations have an opportunity to provide a fueling service beyond the internal combustion vehicle, and we're on the precipice of introducing electric propulsion in the aviation sector, and as well mass transportation market as marine, transit, et cetera, et cetera. So again, it just doesn't stop at the boundary of road vehicles. Section 64 does talk about energy production and storage. Now, this is not the mainstream option that you can actually have in North America or Canada for sure at this moment, but the electrical code does have the provisions for this particular setup. So when your vehicle is paired with the proper equipment, your electric vehicle can now be used as a power source. So it can become a so-called generator. And if you have the system that it's kind of like a transfer switch at the end of the day, that at the loss of main utilities, that your vehicle will become the power source for your home or business or however it is currently set up. Section 68 does talk about the marine industry. So there are some big movements that are happening in marine as well, whether it's going to be for personal or as well for business purposes. And then Section 86, as I have all identified before, that the section does outline all the necessary rules related to the installation of EVSEs. Looking at particular sections now, just to kind of go into the weeds a bit here, is that when we do look at Section 4, we are all familiar with it being in relations to conductors. Now, same deal as before, we need the infrastructure to be brought to the EVSEs so they can basically charge to the vehicle, et cetera. Now, depending on the location of the installation, whether the installation requires a service conduit or it's going to be underground, special attention is required in the planning and as well the installation of conductors for EV charging infrastructure. So now, taking into consideration whether it's going to be public or private, the installation may involve a bank of EVSEs where a feeder is going to be buried. So if we then go to, say, a retail space, a parking lot for a mall or on the side of a road, and you will then see a bank of EVSEs, generally the installation is not done such as from where the distribution is going to be, it's going to be all individualized circuits. There may just be a primary feeder that will feed the distribution, and then it will get split from a distribution system to all of these separate EVSEs. So the primary feeder has to be buried. So there's a whole bunch of underground rules required when you are doing these. So this way they can be split accordingly at the distribution. So things to consider: conductor type. You're not going to bury just any type of conductor. And again, depending on the location, whether you want it armored or just as the direct buried type as well. Burial depth is really important too. So again, local considerations, is it going to be under concrete, under areas that are meant by public or by road? Local considerations such as geological, those are again quite critical. So are they going to be in areas that are going to be super rocky? Is there permafrost and other things that are that may or may not hinder the ability to bury the conductor properly? And as well, municipal. So some of the municipalities may have restrictions as to where some of these installations are done. So again, ecological sensitivity to just straightforward under a road or near services. And then the distance. Well, as we all know, the further you go with the conductor, then you're always going to have to deal with that voltage drop. So these again are small considerations to basically take into account when you're doing the installations, increasing costs, and as well the complexities of the installation. Services and service equipment. Now, the installations that are not tied to existing infrastructure. So as an example, if you go to a standard business or home, well, there is already going to be a service there and you can just tie off from that system. But the moment that you're going to be involving private systems that are just directly fed by BC Hydro, as an example, or if they're going to be on as an installation at a rest stop or a parking lot that isn't tied to a particular business, and even street parking, which may essentially involve street lighting, or it's going to be on its own system, they're going to require their own utility connections and their service equipment. So now system sizing needs to be taken into consideration for that existing infrastructure, or if it's going to be new installation. And then the future intention, whether it's going to be a requirement for expanding that service as well. So when doing these installs, a consumer needs analysis can help determine and as well forecast the system size requirements. The idea, especially for a home, typically, depending as to the municipal requirements, you may require an EV charging system at each parking space, or the home may, especially if it's a brand new home, you can take in consideration the possibilities of having multiple vehicles. Again, relatively innocuous and pretty simple to help work out. But then working with larger systems with the hopes to potentially expand, take into consideration the forecasting of how many EVSEs can be brought into the system at a later date without major system infrastructure changes, really helps the consolidation of planning, and as well as coming in later on to basically deal with the increase. Okay, section 8, my favorite personally is when you're doing load calculations. So this is specifically to identify the demand factors for circuit loading. Did mention it earlier that section 8 does have the provisions for EVSEs and as well for all the load calculations on any building type. Loading requirements will differ based on the installation methods and as well building types. And so the application of an EVSE to a single family dwelling is very straightforward. Unless, there's always going to be an unless in there, where the demand exceeds available capacity. I'm sure we've all worked in a circumstance where you do a load calculation and you are on the peak of that service. So if you look at older homes that only have 100 amps for service, this is where a large market application can be brought into the picture and new technologies. Typically, and in the past, we would have probably just said, well, with a 100 amp service, you are bound to do a service upgrade. And this is, again, one of those things I may or may not essentially sell you, the consumer, to install any type of charging infrastructure into the home. So options would be to, again, upgrade the service, or alternatively, you go to energy management. I'll refer to energy management as EVEMS for short. So it's an alternative that can be introduced that allows for charging infrastructure to be installed without a service upgrade, and you can also minimize the installation cost. From the current systems that I'm aware at the moment in time, usually EVAMs equipment-wise will be about the $800 to $1,000 mark. And compared to saying have to buy equipment for an upgrade, which can again double if not triple based on the equipment used. Now, further into this section that you will then get all of the other types of dwellings based, like it's commercial, hospital, schools, the whole bit. All of those demands do have the provisions for EVSEs as well. And but then we are then going to be referencing a new table in the back that will then do all the calculations based on parking spaces and as well the demands of your EVSE equipment. Section 20, as indicated before, is the introduction of EVSEs, but then considering anything that relates to refueling stations, aircraft hangars, and so forth. In British Columbia, really interestingly enough, there was actually a flight that occurred with Harbour Air, and they were the groundbreaking technologies, and one of the very first flights had been done solely electric for the purpose of commercial transportation of people. So groundbreaking, but then again, this again is just another market that's going to get cornered eventually. Energy production and storage. I did specifically put the F-150 Lightning in play because this is one of the selling features for the manufacturer. As we all know, as electricians, it's not as straightforward as just plugging it into your vehicle and then the vehicle starts to back charge into the system. There's a lot of things that have to be taken into consideration, such as the isolation of power from the utilities. So this way, there's never any type of backfeed onto utility cables. So that's going to require a form of bidirectional switch that will have the ability to isolate the utilities. So it's not something the truck can do because the truck is just the storage means. It's the equipment in the house that's also going to be a requirement. So understanding that is not as simple as looking at the advertising thing the truck could feed your house. So great for F-150s, but unfortunately bad marketing on Ford's behalf because there's a little more involved. But yes, it is essentially one of the things available, one of the provisions for the electrical code that will bring into the market the ability to do so. So anyways, again, just one of the small things to understand about the EV or the CEC. And then in section 86, there's really not much more to explain about it, but the section outlines all the necessary rules related to EVSEs for general information for the equipment, control, and protection, and as well the equipment location. Okay, now another part that I love to go into the weeds, but we'll kind of talk about it just very briefly here for the most part, is the regulations. Because it's not just the electrical code that we have to consider, but we also have to look at jurisdictional requirements, et cetera, et cetera. So when you do look at jurisdictional requirements, they can supersede the CEC due to special requirements. And so in the CEC, the regulations template is going to be for the majority of Canada. There are going to be some differences from province to province, such as Quebec and Ontario, but in general, the CEC is the basic template that will have precedence for most jurisdictions. Some municipalities have specific requirements for the installation of EVSEs and its emerging technologies. So when we look at circuit sizing, location, and energy management, these are certain things that we have to look at in depth, specifically to their availability, basically to the availability, and plus, what the cities and jurisdictions allow. I will give you an example. This is the municipality that I live in, which is going to be the city of Burnaby. But as an example, they do require that all new residential developments be EV ready. And this again is anything that is existing doesn't fall under this particular technical detail, but it is specifically to new residential developments. Now, all parking spaces for new dwellings and does have exclusions are going to be equipped with a 40 amp minimum outlet. Now, considerations to using EVAMs, like the energy management, can reduce having a dedicated outlet at every single parking space. where you can then use it to split a circuit's load. These have to be built in. There's actually quite a bit of planning and as well as paperwork to do so. But again, it's just one of those jurisdictional requirements needed for this for the city of Burnaby. Additionally, performance standards that ensure that sufficient electricity is available to EVSE users for overnight charging based on daily driving distances. Now we're going to be getting into the multifamily units where it then determines well, how many amps per circuit is going to be required based on specifications and a particular table that is introduced by the jurisdiction. Overall, in British Columbia, there are 9 jurisdictions, basically such as Technical Safety BC, and then most non-metropolitan centers do not have any special requirements, but or to say that most metropolitan centers do have some requirements, but not all of them at the end of the day. Usually, if there are no specifications, and again, another example is the city of Kelowna. You don't have a lot of EVSE requirements, and they're constantly evolving, but otherwise the installation is going to be based on the electrical code, and if the jurisdiction requires it, just through Technical Safety BC as well. When we look at any lower mainland city, you have to look for the technical bulletin because it is definitely more than just what the CEC has to offer. So going back again to the city of Burnaby, which outlined a 40 amp breaker, in the CEC, it says that the minimum is 20 amps for an EVSE, but not required, again, depending on city jurisdictions. So really have to understand the little nuances to make sure that you do install properly for any new home. Okay, emerging technologies, another part that I do like to talk about, and I don't have enough time in a day to be able to go into the weeds of this, but I will definitely try my best here for you guys. But when we do look at modern EVs, they've been available for or to consumers for over a decade. Charging technology, on the other hand, has only started to evolve, and this is all going to be based on the demand for electric vehicles and its increase again in the market. Existing infrastructure may have limitations. We've all heard the statements that if everybody changes over to EV technology, that you're just going to burn the grid down. You do talk to Hydro and as well their technical lines about this, and surprisingly enough, Hydro's been in the know for quite a long time, and they've been making sure that the changes are going to be progressing as the needs come in. So there has been plans for this. So it's not as if the market's demand is so great now that everybody switches right away. It is a slow but steep increase at the end of the day to the change, but it's not overnight, unfortunately. Now, existing infrastructure may have limitations. Load demands may be at the system's thresholds, but this is where we are going to be introducing new technologies in homes as well as at utility infrastructure, which is going to be energy management. So this is basically for the EV industry, and it could be tied in with other things as well. But options have been developed to manage EV charging infrastructure to stay within existing limitations through load sharing. There's also priority of use protocols or even sequential rotation. Another example as to the ability for utilities to manipulate how much current is going to certain loads, and especially now with the day of smart meters, is the ability for them to dial in pretty much to certain residences and lower their current capacities, and that's actually just changing the waveform, and you wouldn't even notice that as a consumer, but it is their ability to manage the power output on the hydro lines. Now, installers have to understand the hardware, and it's the requirement for the consumer needs. There's just no such idea of going to a wholesaler, purchasing something that is generic and installing it without having a really good understanding of the system. Now, EV charging systems have the ability to be interconnected for the purpose of energy management. The systems can be connected to a localized controller. The system may require remote access to a management host, but these system specifications have an influence on how the sizing of the circuit and protection will be in the user's domain. So it's, again, not a one-size-fits-all system. There is, again, going to be a bunch of options available based on the installation that you're going to do from one infrastructure to another. When we do look at existing homes and business spaces, and we look at their electrical infrastructure, an evaluation is going to be required to determine the threshold. One really cool part about that evaluation, and if you were to go into the code book and look at Rule 8.106 sub Rule 9, it does state that the load calculation can or shall be permitted to be based on demonstrated loads. Now, in a nutshell, that means that despite the infrastructure that is there, despite the calculation that you've made, and it says that I cannot add any more devices, you can go to BC Hydro or FortisBC, depending on who is your utilities, and get an evaluation, which is the last 12 months of your utilities for that domain, and determine really if you are hitting peaks. So when you're dealing with a multifamily unit dwelling, it would be really tough to determine, especially for an existing building, what their current use is going to be unless you get that information from hydro and utilities. And you can then base your calculative demands on that versus the physical equipment you have on site. So despite the calculated load, the demonstrated load can supersede the calculation and allow for the addition of devices to be added into the planning of your installation. So now the benefit can be a cost savings for the consumer, and so no need for an expensive upgrade, and potentially increases the amount of units that can be installed compared to the calculated load values. Where this is important, especially when it comes to stratas, you're going to be looking at multifamily unit buildings that will say have 50 parking stalls, and then your initial calculation stated that you can only service 1/3, maybe half of those parking stalls. With the demonstrated load, you possibly can determine that, with some minor calculation changes, the whole bit, you can service every single one of those stalls, introducing energy management, and you can actually work within the limitations to provide a service for that entire building. So again, just one of those things that you just have to have a really good understanding in relation to the code and as well to utility requirements. When we do look at EV-specific energy management technology, it's been developed to manage the electrical demand for high threshold buildings and or to increase the amount of EV spacings. Now, the CSA has published a fantastic document that does classify these energy management systems. So there's categories such as load switching, load sharing, load management without monitoring. There's load management with EVEMS monitoring, load management with external monitoring, and as well load management monitoring at EVEMS and external. Now, I'm not going to break every single one of those down because, again, only have so much time, but the different classifications all come with a degree of pros and cons. Can they be expanded? So it means that is the manufacturer-specific protocols that have certain limitations to work with other devices, or is it working with the open charge point protocol that allows you to work between different technologies? Just because, again, it's a kind of like an open source protocol. It can be cost prohibitive, meaning that if you are going to be purchasing higher end equipment and or to say you're going to have remote services monitoring the systems, these are, again, all small classifications, pros and cons. There can also be local technical knowledge requirements, and that just means you may actually have to have IT on site to deal with localized equipment if you choose not to go with remote services or so forth. And the possibility of obsolescence. And this is the one small thing about technology, is that it's not always going to be a guarantee that when you buy it, that within about 10, 15 years that those standards are going to be identical, and there may be changes required to basically keep them up to date. So understanding the behavior of energy management really helps to determine the type of system that's going to be best suited for the installation. If you were to walk into one of your local wholesalers today, you will get a small demonstration for some form of energy management. And I'm not going to go by name at this moment in time, but the one thing you have to understand is that energy management isn't exactly super straightforward, or it's based on what the CEC classifies as energy management, and this is how they can kind of get away with it. You can get EVAMs that behave like a load miser. And for those who are not overtly familiar with load miser systems, it's kind of like a load splitting device that if you have it connected to your EV charging system, and as well a high amp device such as your stove or your dryer, that the moment that you turn your priority load on, such as your load stove and dryer, it'll literally kick out the EVSC, and it's not going to kick it out current-wise. It literally kills it out of the circuit, meaning that it no longer receives voltage. Now, the one issue that I have, or personally a lot of potential vehicle manufacturers or even EVSC manufacturers, is that you are essentially increasing the cycle rate on the charging system. So the vehicle does recognize, how many times the vehicle is basically in charge mode. And after so many cycle rates, and usually the cycle rate is supposed to be for from a 0 to 100 style, but every time you connect, disconnect, that the vehicle records this, and this can potentially have some repercussions with the vehicle itself. And then you look at the EV charging equipment. Well, the problem with that is that whenever you do disconnect an EV charger, it does have to go through a boot up process that could take 30 seconds to a minute. And the EV, the electrical vehicle, may not necessarily reconnect within about 10-15 minutes of that process, or to say it won't reconnect at all for its own safety purposes. So it really has some little interesting nuances working with a load miser style system. There is another company that does offer one that is a little better, and it will only cut out if your service exceeds 80%. And this is just done so with energy monitoring on the service through using current donuts. And this one, again, it's better than the load miser style, but same deal. If you have a tendency of working on the border of that 80% all the time in your home, then you are going to be increasing the cycle rates on your connection and disconnection with the EVSC. So either way, EVAMs get cut off and may cause some minor issues with the charging cycle, maybe delays in reconnecting based on vehicle specifications. But don't fret, there is definitely more of a better system out there. There are some EVAMs that they don't cut the voltage off through, again, energy monitoring of your main services. It can modulate the current based on the service capacity needs, so not cutting out your voltage. So your vehicle actually has the ability to communicate with your EVSC, and as well at least can actually modulate that current safely with those systems. Okay. Now, I have actually been noticing the chats coming in. I will definitely communicate with that after the fact. It is definitely at the 1 hour mark. I do have about another, I'd say about another 11 slides to go through, but we definitely can go on a quick coffee or a 5 or 10 minute break. Actually, Maya, what's your preference, 5 or 10 minutes?
Let's do a quick 5-minute break, Neil, and then we'll
Sure.
we'll meet back up at about 10:07.
By all means.
All right. Thanks, guys. I think we can go ahead and get started back up again. Thank you guys for your patience. And back to you, Neil.
Thank you very much, Maya. Just as an FYI, I do have a list of links for a lot of the resources where some of the information that I did extract most of this off. So at the end, I will just read that to you. And if you have a means of either having it connected to the presentation at a future point, again, it's one of those things that we can coordinate.
Absolutely, that would be wonderful.
Perfect. It was a really interesting comment in the chat talking about load misers, and 100% that when you have a load miser in connection to a dryer, that dryers were originally load based at 25%, which if you were to consider the EVSCs are based at 100%, they do cause some minor issues from a load calculation wise. So it's probably not the best device. So this is why I personally have issues when you go to a wholesaler and they try to sell you these systems, and not understanding what they're selling you at the end can be due cause for either newer contractors going into this type of business or not understanding the small details such as those particular rules. So thanks very much for pointing that out, Craig. Really appreciate it. Okay. Safety. I think this is probably one of the things I've been just drilled into our heads as electricians and contractors, that safety is paramount for every single level of the industry. I do have the consumer and the installer identified, but then if you do look at the code, it also does talk about property. So at the end, the electrical industry is governed by safety, which is why we've adopted standards that have been developed. So we are working with CSA, the electrical code, there's TechSafe BC, there's WorkSafe BC. Individual municipalities also have their own standards as well. But the retail industry has changed significantly. Canadian retailers are mandated to stock equipment that is regulated under strict standards. So we all know that when you do purchase something from a retailer, that those retailers are supposed to sell equipment that has been approved for the Canadian retail industry. So consumers have access to these retail services that span beyond the local shelves now. So when I'm talking about, beyond the local shelves, it's actually a loophole that actually can bypass the regulated equipment, because the online purchasing system is now beyond the Canadian borders. So I'll kind of give you guys a bit of an idea. So you can buy stuff on Amazon, you can buy stuff on eBay, Wayfair. There's a whole bunch of online retailers that you can actually purchase these things from. But because they may not be hosted on Canadian soil, they don't conform to Canadian standard requirements. So those regulations could pose a serious hazards to both persons and property. It's not an uncommon thing that you are going to have a consumer purchasing equipment and requesting for a contractor to do the installation. This is a cost savings. I've done it. Multiple people have done this. Actually, it's not an uncommon practice. The only problem is that if it's not recognized that the standard is not applicable to Canadian installations, a couple things have to happen. One, you're not supposed to install it. Two, you have to see if you can install it by essentially purchasing the proper documentation and having it re-inspected. And then possibly through modifications, you can do the installation, but really, really cautiously when you do purchase stuff actually that is beyond the borders of Canadian regulations, then they do cause some problems to the industry. So most people who do DIY think that it's pretty straightforward. They do the install, then down the road, an incident occurs, whether it causes fire, an injury to a person, or essentially the property, that insurances might not necessarily appreciate that, and they may not be covered. So some very, very unique little applications there. EV infrastructure, when we do look at it, this is really the really crazy part, is that consumers have their hands on these devices. And the span of these devices usually will be anywhere between 1.4 kilowatts at 120 volts, all the way up to 400 kilowatts at 1000 volts. Now, I'm being conservative here. Some of the newer systems that are being put into play for really like extra fast charging, whether it's going to be for the commercial truck industry, for buses and so forth, go higher than these values. So if you think that these cables, that the equipment that's distributing this is packing that much of a punch, that means that safety is, again, going to be extra critical and paramount for the utilization. Installation methods cannot be compromised. And then as well, customer education and advocacy to safety is critical for all of these installations. Now, guidance, I'm going to spend a little bit of time on this because this isn't technically part of the EVITP program, but we do talk about it because this is where contractors and installers and even consumers have to have a really good understanding about the process to bring the beginning of a project to fruition and essentially do it and have a completion of a project at the end of the day. I do like talking about this to contractors because it's not exactly as simple as going on the hunch that someone's going to need energy or essentially EV equipment and saying, hey, you know what, I got a good deal for you. It's actually a pretty stringent process to bring it from like an idea all the way to a factor of completion. So as explained earlier, the growth in the industry for EV infrastructure is, again, part due to customer needs. And I'm going to focus primarily on existing buildings. Whether we look at existing homes, single-family dwellings, duplexes, all the way up to multi-unit systems from small to large apartment buildings. These are the locations that are going to provide you with the most significant challenges, and it's because they are existing. When you are dealing with a brand new install, it's all part of the plan, and it's a lot easier to factor in all the numbers within those planning parameters. But on older buildings, it's basically a very unique, and actually every single building will be unique in themselves. So now, often built before EVs were readily available, the electrical system and the layout of their parking garages are not designed for charging in mind. So, however, a number of solutions have actually come to market today that can help facilitate home charging, even for residents of older buildings. It is worth noting that each building is going to be unique and will require a tailored EV charging solution. And there are definitely general steps to consider during the planning phase, but differences will exist in the end goal approach. So I kind of looked into a really good model that was provided by Energy Canada, or NRCan. And let me just kind of go through a bit of this to give you an understanding as to really how complex it is to try to bring this into the perspective of homeowners, all the way down to the very last check to turn the system on. So now condo boards, strata councils, or property managers have to make a decision to consider installing EV charging infrastructure. And it occurs after they have been approached by a unit owner or even tenant who's purchased an EV, or in considering doing so, who would like the ability to charge at home. Now, who wouldn't want that? You live in an apartment, you've got a parking space, but then you don't want to go to a gas station to charge your vehicle. So a couple of things have to happen. So step one usually is about determining the approach of installing your EV charging infrastructure. This is going to be done at the condo board, strata council level, et cetera, et cetera. It's a discussion that on installations of EV charging infrastructure. There's going to be information gathering, such as types of chargers, access, location, budget, cost allocation, the electrical system consideration, energy management, local context of like the provincial territorial codes, regulations, zoning, bylaws, etc. So many things to consider. Following that, you need to kind of survey residents, as to like who would be interested. If ever you've been part of strata or are in strata right now, you'll you'll come to notice that not everybody has the same intent in mind. Not everybody has the ability to spend that kind of money on your projects. It's actually quite a rallying cry just to be able to get everybody to conform. You're dealing with multiple people. And then afterwards, it's outlining an initial approach to the EV charging. So are you just wanting to install for the immediate, or are you looking at future considerations? Now, the following step does represent the point in the installation process where the condo board, the strata council, property managers will then seek out an electrical contractor or even an engineering firm. Simply just, or even actually it can be a provider that does strictly EV and EMS installation processes. But either way, they need to find someone that can basically advise as to the feasibility of installation for EV charging infrastructure. So that process is tedious. Again, from the contractor standpoint, whether you're going to be the engineering firm or just dedicated installers, seeking out that particular qualified contractor is not exactly the easiest task for a lot of people. So the questions that are going to have to be done through the initial consultations, again, how many EV chargers need to be installed? What types of EV charging stations should be installed? So as I mentioned earlier, it's not about, here, I got this great solution just because I have a warehouse full of these and they'll fit your installation perfectly. It's not so much of that, actually. It's just really having an understanding what the installation requirements for that particular building is going to be. Does it require an electrical permit? Well, that's a question that would be at the strata board. As contractors and electricians, we are aware that it will require an electrical permit. What's involved in getting the power to the EV charger? Can non-EV users use the charging stations? How much will the installation cost? That's always going to be at the top of anybody who lives in strata. And after that, what are going to be the costs involved with EV charging once the stations are installed? And that's, again, a big factor, is that it's not just about getting them in place, it's about the maintenance at the end of the day. Following that, you got to look at the electrical and architectural plan review. Then there's going to be the energy data assessment that involves existing electrical service of the building, the remaining spare capacity, charging system voltage compatibility, and future demand for power. So it's not about just peaking the capacity. It's just asking, it's like, well, what are going to be the future demands for that space? And the one part that's always the most fun is going to be the site evaluation to determine, the process of installation. During the information gathering and basically an assessment to this process, electrical contractor, the engineering firm, or so forth can produce a preliminary design, provide options to the condo board, strata council, and as well property manager for consideration. My apologies, not what I was looking to do. There we go. Design documentation and contracts, in other words, physical, the proximity to power source, the parking supply, parking layout and design, the connectivity. Talking about the technical, meaning that the EV charging stations, the networked or non-network system, the electrical capacity. And then the financial, about the installation costs, operation and maintenance, and again, time of use, demand, charges. Now, that one isn't so much on our part, but then if you have individualized charging systems that are not based on particular metered systems, then that's actually something that can work within the strata board. And then there's also preliminary design and eventually the approval of design and award of the contract. So this is a lot of work that contractors or even engineers have to navigate condo and strata boards to work with, because to the general layperson, in terms of understanding the process for these, it's not so straightforward. We live in a very unique world when we actually work with contracting, and this is just one of those things that you have to navigate people to kind of get them to spend money on new infrastructure. During the information and gathering, again, same deal, planning and design completed and approved, received from the condo board, strata council, or property manager, the installation can proceed. That means that you prepare for the install, securing permits, installation, compute, final inspection. This is the general stuff that we deal on a daily basis. No real need to go into detail for this. And then once the project is wrapping up, Essentially, we got to look at the ongoing operations and maintenance. Now, this is possibly one of the harder sells for a lot of strata boards, is to convince them that they do need a maintenance program, and why that is really important. And if you were to be part of the EV world today, that you can believe that there is an actual EV charging system that's nearby and operational, but you get there and it's not operational. And then you kind of hunt as to why it isn't. And a lot of private businesses who initially thought by having equipment on property would attract people are coming to realize that if they don't maintain their systems on the regular, then they can fail on the regular as well. EV equipment is mechanical inside. That is, again, by specific standards to cut out energy from the cord and connector. So these mechanical parts within a system through a specific cycle period can fail. There could be humidity or moisture buildup actually within the systems, communication failures, anything. These systems aren't foolproof. They're built, to withstand heavy usage, but at the end, any public facility or infrastructure that is being used can have failure points, especially if you have to put your hands on the system. So a lot of consumers or a lot of retail businesses or private owners didn't take that into consideration. There may be maintenance requirements for that, and it wasn't exactly explained to them that if they would go with a planned maintenance or subscription service or anything that will allow them to get someone to come and look at these systems regularly, there wouldn't be as much downtime. So operations maintenance is just as important as the installation process. And pretty much, I would say it's just one of those selling features at the end of the day if you are going to work with a particular company or with a strata board. And then at the end, you also have to finalize and approve the electric vehicle charging policies. All stratas are going to be different if it's going to be public use or if it's going to be just for those who are resident or those that have existing vehicles, or if it's going to be for all. There has to be certain policies put into place. A lot of it can be done electronically where it's fobbed or there's time of use, et cetera, et cetera. So a lot of things to consider for every single situation. Now, I do point out customer service because ironically, when we do work in the contracting world, there is going to be the interfacing with consumers, and this is really critical. So now the installer needs to understand the products that are going to be available for the customer and their needs and the available services needed for management and maintenance of the charging infrastructure. I would say that going a step further is even better because a lot of times, as much as a consumer believes that they are just dealing with infrastructure, having an understanding as well as to their vehicles is also really important. Now, not all of us are going to be gearheads. Now, fortunately, this is not an internal combustion engine. I understand the process of essentially a four-stroke system and the general aspects of an engine, but to be honest, if I had to go repair one, I probably wouldn't know where to start. But when we're dealing with electric vehicles, I become extremely well versed in understanding, that it's a straightforward system, especially when we're dealing with the numbers such as kilowatt hours for the batteries, how much time you can actually use for it. It goes beyond just what the manufacturer is providing for you. So as a contractor, understanding what the consumer needs are going to be, so understanding the vehicle that they have, the size of batteries that are going to be on board, and be able to talk to them about, what's their needs are going to be, that is also kind of critical. And then when you are working with the consumers, and especially dealing with a consumer that's dealing with multifamily units or commercial or retail, they are all going to bring to the table about, well, what kind of rebates can I get when I do these installations, whether it's going to be the rebates for the installation as well as the equipment. And there are actually quite a few rebates available through partnered programs through BC Hydro and the provincial federal government. So now creating the EV Ready plan is probably the most critical element of it all. There is a template on BC Hydro But I wish I would be a little more well-versed on creating these, because it's going to be on a unique basis for every single installation. But for the most part, the information is available online at BC Hydro's website to deal with these. So these, again, are critical elements to the customer's needs. Going back into the comprehensive maintenance program, I kind of already pretty much hit that stone earlier on, but if a consumer does choose a service plan from a particular manufacturer, then the most common issue is going to be with your EVSE downtime. But most obviously, it's just going to be maintenance complacency from the consumer's part. So if you are subscribed to a service that can identify that there are going to be some issues before the problems do occur, then they have the ability and power, and I'm talking from the maintenance provider, to simply send out a service such as a contractor or so forth to go and deal with them right away. But yeah, at the end of the day, there are going to be costs associated with maintaining EVSE systems, but at the cost of being able to do that on a maybe 6-month or yearly basis for a consumer, it'll end up being cheaper than having downtime where you are no longer getting any type of monetary fund for the EVSE, especially if you have it for the purpose of monetary service as well. So if it's not giving you money, then there's no sense in having that system at the end of the day. You want to be able to have that thing uptime all the time to make sure that you don't miss out on those opportunities. Now, as the market grows in Canada, it's imperative to understand that this is going to be the mainstay of our business. You actually have a lot of car manufacturers now that are promising that by year 2020 or 2030 or 2025 or so forth, that they're planning to completely phase out their internal combustion engines. So that is huge. I think it's imperative for us to be on top of our game to be able to offer these services immediately or readily, because it's not every building, not every consumer who is on board right away and changing. But then if all of a sudden there are no other options but to go to EVs, that will change the growth period. In other words, we are going to be peaking to be able to get these installs done in as quick as possible. So given that the significant proportion of charging currently occurs at home, we have to ensure that all Canadians have access to where they live, which will be the key to facilitating widespread EV adoption. So recognizing the importance of addressing some of the most critical barriers associated with charging is therefore integral to further uptake. So the installation of EV infrastructure in multifamily units is complex, but yet it is unquestionably important given the commitment to the continued development of EVs across the country. So a great understanding of the installation process is key, not necessarily just for the consumer, but as well as for the installer. So when we do look at that, it's going to be the owners, councils, the contractors, and as well those who are providing the installation service. So our position in the industry is to support those that are involved with the installs. We provide an industry-leading program which supports electricians and contractors, and again, that refers to our EVITP program. And we want to make sure that you're equipped with the necessary knowledge to successfully support the customer in all phases of the installation. And that's it. Thank you very much for your attention. Maya, you have the floor.
Yeah, thank you so much, Neil. Yeah, it's okay. Thank you so much, Neil, for the presentation. It was absolutely wonderful. And I would like to invite the folks that are on the call to either enter questions into the chat box there for Neil, if you have any questions about the information that was covered today. Or if you feel like you would like to unmute yourself and ask a question directly, we're welcome to do so. It's a fairly small room, so we can manage that as well. I also want to take a moment to thank both Danielle and Jalissa for joining us today from the Community Energy Association. They've been helping me with facilitating these webinars, and it's been really wonderful to have your support in this. So thank you both for being here. And I believe, Danielle, we also have a survey link to share with folks. So maybe we can pop that in the chat while we're waiting for questions to come in. There it is. So the survey is simply to get your thoughts on today's webinar and how useful it was for you today. The idea is to help us improve these webinars going forward. It's not collecting any personal information, so it's entirely anonymous, and we really appreciate your feedback. But yeah, any questions or comments for Neil? Also go ahead and share the upcoming events that are happening as well. Okay.
So as indicated earlier, is that I've any information that you're interested in, I do have the links to the NRCan, to the CSE documentation, or to as well identify any additional training days that we have for our EVITP program. We do have some sessions that are up and coming in the future, and it is it's pretty much 4 8-hour sessions with an exam towards at the end that can essentially be the basis. Actually, my apologies, 3 8-hour sessions with an exam. So it's a total of 24 hours of instruction. And the exam is pretty much based on codes and regulations for the primary part. So yeah, you're welcome to inquire about that. And I can also give the link to Maya.
Yeah, that'll be great. And we'll make sure to send all of the relevant links to the folks that are here today and those that are registered. So should be seeing those in your inbox. And yeah, I see Justin asking, will there be an online course coming up? Neil, do you want to speak to that?
Certainly. So right now the course is delivered, whether it's going to be in person or online. So it is live online. So if you're referencing online to being such as like a Zoom meeting, yes, we do actually have one coming up. Actually, I'll have to kind of look that up right away to see when the next available date is, and I can post that to you right away.
And I will say that we're also working on, because right now the examination component is in person over in Port Coquitlam, but we are currently working together with the EJTC and Camosun College to provide in-person examination dates here on the lower Vancouver Island. So just so you guys are aware that that is something that's underway.
All right. All right, so I'm just going to put the link for the registration of our program to give you more information. And if it doesn't provide you with enough information, you're more than welcome to just give us a call, and we'll be more than glad to answer any of the questions you have.
Okay. Well, I think we're going to go ahead and say that if anyone on today's call has any follow-up questions for either Neil or myself or yeah, just in general on the topic, feel free to reach out. Absolutely happy to hear from you. Thank you so much for attending today, and huge thank you to Neil for your time and going through this presentation. Lots of really crucial information there, so I really appreciate it.
No, you're absolutely welcome. Thank you.
Yeah. Wonderful. Okay, and yeah, so I guess we'll go ahead and call it there. Thank you guys so much for attending, and have a wonderful rest of your day. Bye, everyone.
Thanks, Matt.